Hi everyone. So let's talk about the order statistics in this lecture. So let's begin with the definition of order statistics. Simply, when we have an independent and identically distributed variates, then we can arrange them in ascending order as we can write the variables with given CDF and with given PDF. Then the order statistics will be in ascending order. Like if or let x1, x2, x3 up to xn be n independent and identically distributed variates, each with cumulative distribution function and probability distribution, a probability density function. Probability density function. If we have the random variables which are IID with cumulative distribution function and probability density function. If these variables are arranged in ascending order, ascending order of magnitude and written as x1, x2, x3, x4 up to xn. See, if we have the random variables which are IID with cumulative distribution function and probability density function, then the variables are arranged in the ascending order of magnitude and they are written as, for this is called the first order statistics is less than second order statistic is less than third order statistics is less than nth order statistic. So this is first order statistic, this is nth order statistic, and somewhere between x1 and xn there must be rth order statistic. This is rth order statistic. Rth order statistic. So order statistic is simply when we arrange our random variables in order. Like we talked about the x1, xr, xn. These three are most important. X1 is smallest order and first order statistic. XR is rth order statistic. And Xn is maximum order statistic or largest order statistic or nth order statistic. Yeah, right. So let's discuss them one by one. What is the PDF of first order statistic? What is the PDF of nth order statistic? And what is the PDF of rth order statistic? See, the order statistic is applied only when you have the probability density function or you have the cumulative density function of some random variable x. Remember, first you have some random variable x at the initial then you can only write the uh, order statistic of that PDF or that random variables, right? So see, let's write the heading single order statistic. We have the random variables, that's x1, x2 up to xn, right? Then we have to write the single order statistic, that's x1, xr, xn. Now we are going to find the PDF and CDF of that order statistic. Now let f of rx, where r is equal to 1, 2 up to so on, denote the CDF of the rth order statistic, that's x r. Then the CDF of f of nx of the largest order statistic, that's xn, is given by. Now we will try to find the PDF and CDF of nth order statistic. Nth order statistic. See, as you know, what's the PD? What is the CDF? CDF can be written as f of x, capital F of x, which is equal to probability x less or equal to small x, right? Which is also equal to minus infinity to x, f of x, x dx. Is this clear? This is my CDF. This is my CDF. From the distribution functions, probability distribution function, you may be knowing that CDF is written like this. CDF is written like this. Now, see, f of nx is equal to probability xn less or equal to small x, which is also equal to probability xi less or equal to x, where I is equal to 1, 2 up to so on, right? So this can be written as probability x1 less than small x intersection x2 less than small x intersection x3 less x3 sorry intersection x3 less than small x intersection xn less than small x. Is this clear? And if random variables are IID, so we can write them separately. That's probability x1 less or equal to x less or equal to x into probability x2 less or equal to x into probability x3 less or equal to x up to probability xn less or equal to x. This is because xi's are IID. Remember, whenever you talk about the order statistics, let's suppose x1, x2 up to xn, x1 and x2 are independent of each other, x1 and x3 are independent of each other. It means that order statistics are independent to each other. Now see, can I write this as this is a product of n terms? This is written like this: probability x raised power n. Now we get the CDF of nth order statistics, that's CDF of nth order statistic. CDF of nth order statistic, that is f of x raised power n, f of n x raised power n. Now a simple trick to find the PDF of any CDF from any CDF, we simply do one thing. As you know, whenever we have the PDF and we try to convert this PDF into CDF, we do integrate. We do integrate of that PDF, right? So this is my PDF. This is my PDF and we will get CDF. From PDF to CDF, we integrate the probability density function. Probability density function. Now, from CDF to PDF, we differentiate CDF. Now, this is f of x. Now, d upon dx, f of x will give us PDF. Simply from PDF to CDF, we integrate the PDF function. And from CDF to PDF, we differentiate the CDF function. Simply. CDF, f of nx raised power n. Now differentiate this function, what we will get? We will get n f of nx n minus 1 into d upon dx. This is f of xx. Internal differentiation of this, or write the PDF. This is PDF of nth order statistic. This is PDF of nth order statistic. And this is CDF of nth order statistic. Right? This is PDF of nth order statistic. This is CDF of nth order statistic. Right? Now talking about the first order statistic, that's x1. Now what's f of 1x will be probability x1 less than small x. And this can be written as 1 minus probability x1 greater than x. Whenever you have the first order statistics with less than equal to sign, try to convert this into this. Try to convert that into this. So this is equal to 1 minus probability xi greater than x, where I is equal to 1 to up to so on. So this is 1 minus probability x1 greater than x, probability x2 greater than x, up to so on. So this is equal to 1 minus probability xi greater than x, x1 greater than x raised power n. So as you know, probability x greater than x plus probability x less or equal to x is equal to 1 in case of continuous. So this is equal to 1 minus probability xi is less than x raised power n. So this is equal to 1 minus f of xx raised power n. Right? This is xi, right? So this is the CDF of first order statistic. This is the CDF of first order statistic. Now PDF, d by dx of 1 minus f of xx raised power n. So this is equal to differentiation of 1 is 0. This is minus this is n minus n 1 minus f of xx raised power n minus 1 into internal differentiation, that's minus f of xx, which is equal to n 1 minus f of xx n minus 1 into f of x. Is this clear? This is the PDF of first order statistic. This is the PDF of first order statistic. Clear? So now you know about the PDF and CDF of first order statistic as well as nth order statistic right? So now talking about the rth order statistic. Simply you don't need to find the CDF of rth order statistic. Only I will give the formula to calculate PDF of rth order statistic. That is f of rx, that is equal to n factorial upon r minus 1 factorial n minus r factorial f of x r minus 1 into PDF into 1 minus f of x raised power n minus r. So whenever you are trying to find the second order statistic, third order statistic, fourth order statistic, you can use this formula. As you know, first order statistic is that we see that the PDF and CDF of first order statistic, and similarly for nth order statistic, and then we have the formula of nth order statistic, or we can write this as 1 upon beta r n minus r plus 1 f of x r minus 1 f of x 1 minus f of x n minus r. Also, you can write the ortho order statistics PDF of ortho order statistics like this, right? Like this. Now you know what's first order statistic, what's the largest order statistic, what is rth order statistic, right? So this is your order statistics of first order statistics, nth order statistic, and rth order statistic. Now joint PDF of two order statistic. Simply for joint order statistic f of rs, I will give you the formula to calculate this. This is simply equal to n factorial upon r minus 1 factorial s minus r minus 1 factorial n minus s factorial. Then f of r minus 1 small f of x, and then capital F of y minus capital F of x raised power s minus r minus 1 multiply f of y 1 minus f of y n minus s. This is your joint PDF of two order statistics. Whenever you are talking about the joint PDF, when we are talking about the order statistics, then you have to apply the formula. As you know, if random variables are IID, see how we can find this. If f of x comma y is given, as you know, f of x comma y is equal to f of x comma f of y. So this is when random variables are IID, and in case of joint distribution, random variables must be IID. So you can easily find the f of x and f of y. Then from this you can easily find the capital F of x, and from this you can easily find the capital F of y. So put f of x, f of y, that's capital F of x, capital F of y, small f of x, small f of y. In this you will get the joint PDF of order statistic. Let's suppose you are asked to find the f of 3 comma 1, that's n factorial 3 minus 1, so 1 minus 3 minus 1, which is absurd. So here here if we say f of 5 comma 4, 5 comma 4, yeah, 4 comma 5, if you are asked to find the f of 4 comma 5, so this is n factorial 3 factorial, this is not 3 factorial, this is only 3, this is only 3. See, this is n minus r minus 1 factorial here. Sorry, this is r minus 1 factorial. So this is 3 factorial. This is 5 minus 4. That's 1 minus 1. That's 0 factorial. That's 1. That's 1. Or 0 factorial is 1. Then we have the n. N is 4 minus 5. That's minus 1. This is also incorrect here. Negative factorial is not exist. So if I say, yeah, if I say 4 5 4 comma 4, that is n factorial, 4 minus 1, that's 3 factorial, this is 4 minus 4. What's the limitation here? What is the limitation here? What's the limitation here? Yes, limitation is you only apply this when r is greater or equal to 1 or less or equal to s, less or equal to n. So this is valid when this equation, when this inequality holds for this joint PDF, for this joint PDF. ये तब valid होगा जब ये joint PDF के लिए valid होगा. So let's see, r is equal to 1, s is equal to 2. So if we put, and we do not know the n, what's the n, what's the sample size, or what's the random, how many random variables are there. So r is equal to 1, 1 minus 1 factorial, 1 minus 2, that's minus 1, s minus r, r is 2 minus 1, 2 minus 1 is 1, 1 minus 1 is 0, 0 factorial. So this is n minus r, n is, yeah, we are correct. We were correct. So see, now this is the joint PDF of two random variables. Now see, you have to remember what I am going to talk about now. See, let's suppose x follows uniform 0, 1. Let's write this as example. X follows uniform 0, 1. Now this is the limit of this is from 0 to 1. X is greater than 0 and less than 1. See, you do not need to calculate PDF, CDF. Simply, whenever this x follows uniform 0, 1 comes to you, you can simply write xr will follow beta r comma n minus r plus 1, or x1 will follow beta 1 comma n minus 1 plus 1, or xn will follow beta n comma n minus n plus 1. So see, you have to remember this for now. And some most important questions will be asked from this question, that x follow uniform 0 comma 1, then what will be the PDF of xr, then find the expectation of xr, variance of xr. As you know, this is beta 1, so expectation of beta, that is m, if x follows beta m comma n, then expectation of x is m plus n. This is n plus 1, sorry. This is m plus n. And variance of x will be mn m plus n whole square m plus n plus 1. Right? When x follows beta m comma n, expectation of x is mn m plus n, variance of x is mn m plus n whole square m plus n plus 1. Clear? Clear? So when x follows uniform 0 comma 1, then you have to remember these three. You have to remember these three. Let's write an example here. Example is, if we are given with f of x is equal to 1 0 and x is between this, and we are given with n is equal to 10, and x1 up to xn follows IID. Clear? Now find expectation of xn, expectation of x1. Now see, here x follows uniform 2 comma 3. Now what's the CDF of this? That's x minus 2 upon 3 minus 2 will follow uniform 0 comma 1. We have the result for uniform 0 comma 1. That's why I did a transformation here. That's x minus a upon b minus a. That's the CDF which follows uniform 0 comma 1. See, when x follows uniform 0 comma 1, so CDF of x will also follow uniform 0 comma 1, and 1 minus x will also follow uniform 0 comma 1. Remember this. So this is x minus 2, or simply x1 will follow beta 1 comma n is 10 plus 1 minus 1, and xn will follow beta 10 comma 10. This is 10 this is 10 minus 1 plus 1. This is 10 minus 10 plus 1. So expectation of x1 will be 1 upon 10. Why? Because m plus n. This is my m, this is my n. So variance of x1 will be mn, that's 10, m plus n, that's 11 square, that's m plus n plus 1, that's 10 plus 1 plus 1, that's 12. So which is equal to 10 upon 1 to 1 into 12. Now calculate this, you will get the answer. And expectation of xn will be 10, variance of xn will be mn, that's 10 upon 10 plus 1, that's 11 square, that's 10 plus 1 square, 10 plus 1 plus 1, that's 12. m plus n plus 1. This is m, sorry, see, this is m plus n, that's 10 plus 1, that's 11 square. This is 10 plus 1 plus 1, that is 12. So this is the expectation and variance of x1 and xn. x1 and xn, right? x1 and xn. Or if you are asked to find the expectation of 1 minus x1, what will be the value of this expectation of 1 minus x1? Now here we are using the property that's when x follows beta m comma n, then 1 minus x follows beta n comma n. So expectation of this will be, so 1 minus x1 will follow beta. What's x1? x1 will follow here 1 comma 10, then 1 minus x1 will follow 10 comma 1. So then the expectation of 1 minus x1 will be m, that's 10 by 11. 10 by 11. This is the property. Go and check the beta distribution. You will find this property. You will find this property. You will find this property. Now, most important concept here. What is that concept? Let's see. See. Remember, x follows uniform 0 comma 1. Find probability y1 less than 1 by 2, y2 less than 1 by 2. That's equal to 1 by 2. You have to prove this. This is equal to this. So x follows uniform 0 comma 1. Then for I is equal to 1, 2 up to 5. Then y1 is equal to x1 upon x2. That is simply xi upon xi plus 1. This is the property. Yi, or simply yi is equal to this. So y1 is equal to x1 upon x2. Acha, y2 will be equal to x2 upon x3. So this is a transformation simply. So we have to find the probability of this, and what's f of yi? That will be I minus 1. Or you are asked to find the f of y2, that's equal to 2 y, 2 minus 1 is 1, that's 2y. Similarly, see, from this, as you know, this is order statistics. This is order statistics. X, y1, y2 is order statistics. As you know, I told you that y1 and y2 will be independent. Now, using the conditional distribution here, probability y1 is less than 1 by 2, probability y2, this is equal to here, equal to 1 by 2, given probability y2 is equal to 1 by 2. So whenever this is independent, then this and this will goes. So we will be left with probability y1 is less than 1 by 2. That is equal to probability y1 is equal to 1 by 2, and the PDF of f of y2, that is 0 to 1 by 2, 2y, which is equal to 2 y square upon 2. This and this goes, that is equal to y square, this is 1 by 4. The probability is 1 by 4. The probability is 1 by 4. But this should be equal to 1 by 2. This should be equal to, okay. See, I write the PDF of f of y2. I should write the PDF of f of y1. So what's f of y1? That's equal to 1, 1 minus 1, that's 0. Simply this is 0. 0 raised power, anything raised power 0 is 1. So this is 1, 0 to 1 by 2 dy. That's equal to 1 by 2 is my answer. This is my answer. This is my answer. Now, another formula in the uniform distribution, that's a difference formula. X follows uniform 0, 1. Xk minus xs will follow beta first kind k minus s n minus k minus s plus 1. n minus k minus s plus 1. Now, the questions from fundamental of mathematical statistics, that is, let x1, x2 up to xn be a random sample from a population with continuous distribution, then show that y1, that's minimum of x1 up to xn, is also exponential with parameter n lambda if and only if xi's are exponential with parameter lambda, See, what's the question? Question is x1, x2, xn will be is a random variables from a population and continuous distribution. Show that minimum of this will follow exponential with n lambda. So see, when x follows exponential lambda, then first order statistics will follow exponential n lambda. So multiplying with this n, right? If x follows exponential lambda, then x1 will follow exponential n lambda. So this is the property. We have to prove this property. From the this question is most important from your exam point of view. So let's see it carefully. So see, first we write the PDF of exponential distribution, that's lambda e minus lambda x, where x is greater or equal to 0 or lambda is greater than 0, right? Now, what's the f of x of this? That is 0 to x lambda e minus lambda x dx, which is equal to lambda e raised power minus lambda x divided by minus lambda 0 to x. Why? See, exponential minus lambda, as you know, integration of e raised power x is e raised power x only. Expect integration of e raised power minus x will be e raised power minus x divided by minus 1, and e raised power 2x will be integration of e raised power 2x will be e raised power 2x upon 2. So this is the integration of e raised power something, right? So this lambda and this lambda will goes, so we will be left with minus e raised power minus lambda x plus 1, and this will be equal to 1 minus e minus lambda x, 1 minus e minus lambda x. So CDF of this is equal to f of xx is equal to 1 minus e minus lambda x, right? Now as you know f of x of first order statistics is, what is the CDF of first order statistics? That is 1 minus f of x raised power n minus 1. Sorry, that is PDF. This is raised power n. So which is equal to 1 minus what's f of x? That's 1 minus e raised power minus lambda x raised power n. So from here, this one will cancel out with this one. We will be left with 1 minus e raised power minus n lambda x. Is this clear? Yeah. Is this clear? Yes. So see, now differentiate this with respect to x. So this is d upon dx. 1 minus e minus n lambda x will be equal to d by dx of 1 minus d by dx of e raised power minus n lambda x. So differentiation of this is equal to 0 minus differentiation of this is same minus n lambda x multiply minus n lambda, because n lambda is constant here. So this is equal to minus minus plus, this is n lambda e raised power minus n lambda x. So see, x1 will follow exponential n lambda. So what I did here, simply to get the PDF of first order statistics, we differentiate the CDF. So hence proved. Hence proved. Now another one question, that is if we are given with f of x is equal to e raised power minus x, x is greater than 0 or equal to 0, lambda is equal to 1, then the CDF of xn, that's f of nx, which is equal to 1 minus e minus x raised power n. This is the CDF of this, of the first of the exponential distribution. CDF of nth order of exponential distribution is like this. Then prove if n tending to infinity, xn minus log n tends to exponential minus exponential x, Simply we have to find the CDF and PDF of this. Let's write this as y. So we have to find the PDF and CDF of y. Simply remember, whenever you are facing these type of questions, let y is equal to this function. And apply the CDF technique. So see how. See. Let's understand this again. जब भी आपके पास कोई भी ऐसा क्वेश्चन आएगा, कि आपको CDF, आपको PDF गिवन है, तो PDF से पहले आप देखो यहाँ पे क्या है xn, तो इस PDF से पहले xn का CDF निकालो, क्योंकि xn ही पूछा गया है ना. xn माइनस लॉग को छोड़ो, ये हम शिफ्ट करेंगे, बट मेन काम है xn पे. xn का आप पहले CDF निकालो, बट इस क्वेश्चन में ऑलरेडी गिवन है तो निकालने की जरूरत नहीं है. देन ये जो है दिस क्वांटिटी, दैट्स क्वांटिटी y, दिस विल बी इक्वल टू दिस, मतलब जब इसका PDF इसके बराबर होगा. देखो कैसे, या PDF या CDF, बट एज n टेंडिंग टू इंफिनिटी. जब भी एज n टेंडिंग टू इंफिनिटी, या तो आपको n को टेंड कराना है लिमिट n टेंडिंग टू इंफिनिटी, तब हमारे पास जो भी सॉल्यूशन आएगा वो इस फॉर्म में आएगा, e raised power minus x. सी हाउ कैसे. What's f of x? That's e raised power minus x. x is greater or equal to 0. And what's f of nx? That is 1 minus e raised power minus x raised power n. Clear? Now, अगर हम इसका CDF निकालेंगे x n minus log n का, वो क्या होगा? y is equal to x n minus log n. ये तो हमें टेंड कराना है ना. सो अगर मैं ऐसे लिखूंगा, probability y is less than small y, which is equal to probability x n minus log n. X n minus log n is less than y. So which is equal to probability x n is less than y plus log n. Clear? Y plus log n. So this is equal to, what is this is f of nx. क्या है ये? f of nx है ना. probability xn is less than, तो ये तो CDF है ना xn का. CDF क्या था xn का? वो तो क्वेश्चन में गिवन है. That was 1 minus e minus x raised power n. अब x की जगह आपको ये वैल्यू पुट करनी है. This is equal to 1 minus e minus y, क्या था? y plus log n raised power n. क्लियर है? So see, अगर मैं यहाँ पे एक काम करूंगा, 1 minus e raised power minus y minus log n raised power n. अगर मैं अब यहाँ पे एक और काम करूंगा, 1 minus e raised power minus y, अगर देखो ये तो दोनों पे है ना, e raised power minus y, e raised power minus log n, तो इसको मैं ऐसे लिखूंगा, e raised power log n raised power n. As you know, e and log will cancel out each other. We are left with e raised power minus y divided by n raised power n. So this is equal to limit n tending to infinity. इसी पे तो हमें देखना है ना. This is 1 minus e raised power minus y divided by n raised power n. Now see, इसको हम कैसे सॉल्व करेंगे? As you know, when you are this indeterminate form 1 raised power infinity, then we use the formula limit n tending to infinity e raised power limit n tending to infinity f of x g of f of x minus 1 into g of x. So see, similarly we will do this thing here. So this is e raised power limit n tending to infinity 1 minus e raised power minus y divided by n minus 1 into n. So this and this goes, we will be left with e raised power minus y. That is also equal to e raised power minus x. And this can be written as n tending to infinity x n minus log n tends to e raised power minus x. Hence proved.